Sure. We can get started now. Can you confirm that you can see my slides? Cool. All right, let's get started then. So, hi all, my name is Julien. I'm one of the co-founders of Argent, and today I'll be speaking about Argent X and more broadly about accounts on StarkNet. This is, I would say, an iteration on the talk that I've done before. So if you've already heard me speaking about that, I apologize. But hopefully there'll be a few new stuff that you'll find interesting. Okay, so before we can talk about accounts on StarkNet, I think it's important to recap what are accounts on Ethereum so we can understand the differences. So on Ethereum, we know that there are two types of accounts. There's externally owned accounts, or EOAs, and then there's contract accounts, which can have a bytecode and execute some logic. And EOAs are the ones that are the most interesting for us because they are the accounts that users interact with. And so an EOA has basically three key properties: an address for identification, a nonce to make sure transactions are unique, and then a balance in ETH to pay fees to miners. And we say that a user owns an EOA through a pair of cryptographic keys, also called a signer. So it's a public and private key. And the link between the signer and the account is made through the address of the account because it is derived from the public key, and only the private key can trigger transaction from an account. Okay, and on the EVM in Ethereum, everything is hard-coded in the EVM. So if we try to represent that, we basically see that on Ethereum, an account is two things: a signer and then the account on chain. But actually, these two things, there are two sides of the same coin, if you want. Right? And so we can actually see that on Ethereum, the concept of the account, the object that holds your token, is completely merged and coupled to the concept of the signer, the object who is authorized to spend your token. They are literally two sides of the same coin. And actually, that's a problem. Why? Because if the signer is the account and vice versa, that means that if you lose your signer, you've lost everything. And if I have your signer, I have everything. And of course, the past years of Ethereum and blockchain in general have proven that has a lot of consequences. We hear stories of users losing access to their account every single day, or users whose account or private key or seed phrase has been compromised and losing everything. So basically on Ethereum, because of the design of accounts, the entire security of accounts and users' fund relies on the users managing a single secret that people call the private key, the seed phrase, and so on. And this secret is such that you cannot lose it or it cannot be compromised. And there's no safety nets. And of course, I think the history of blockchain has shown that this will not scale to mainstream users. If the goal is to onboard 1 billion users on blockchain, it will not work. So we cannot build a financial internet where users need to protect a single secret at all costs. I mean, the web has shown us that securing a password is complicated. People do lose passwords. So, of course, we cannot accept to continue on that same paradigm. So the question is, can we do better? Is there a better way to manage accounts? And actually, there is. It's called account abstraction. The idea of account abstraction is to actually decouple that relation between the account and the signer. And it's something that has been discussed for a while. I think the idea was proposed by Vitalik Buterin on Ethereum almost 4 years or 5 years ago. And every single year he's proposed a new design to implement that. But of course, bringing that to Ethereum has proven complicated because there's already a lot at stake. Right. So the idea of account abstraction is to basically say that the account, the user-facing account, becomes a smart contract, meaning that we can have custom logic to define what is a valid transaction for that account. For example, you can use different cryptography, different signature schemes, or use a different elliptic curve. Or maybe you want an account with multiple signers, like a multisig, like a native multisig, or you want to rotate the signer key. All of this is possible because with account abstraction, your account is a smart contract that you can program. And what's very exciting is that StarkNet is actually the first blockchain was decided to implement native account abstraction. And because of the possibilities of account abstraction, hopefully I will try to show that in the rest of this talk, it really enables to build amazing and much better user experience. Okay, so on StarkNet, accounts are smart contracts, but of course they cannot be any smart contract. They need to comply to a certain interface such that the KROS can interact with these accounts. And so this interface is basically made of three or four methods that I will briefly explain. I just want to highlight that this is the target interface that we are aiming for. StarkNet is still in alpha, so not all the features are there. And actually, if you look at the e-account interface today that you can check on the OpenZeppelin repo or the Argent repo, you'll see that it's not exactly what I'll show here, but so just to remember that this is what we are going to. So when StarkNet will be in production, the e-account interface will have exactly that, these methods. So what are these methods? The main two ones are the method to validate and execute transaction. And for those who've looked at account before on StarkNet, you'll notice that today there's actually only the execute method. But with KRO 0.10, which will be released at the end of this month, the execute method will be finally split between an execute and a validate. So we are gradually moving towards having that interface that I'm presenting. So two key methods to validate and execute transaction. Another method is called isValidSignature, and it's there to verify signatures on off-chain messages. I will come back to that because as a dApp developer, actually this method is very important. And finally, another thing that we can see on that interface is that the input of the execute and validate is not actually one call or one transaction. It's actually an array of calls, meaning that StarkNet account supports multi-calls by default. And I'll come back to what a multi-call is. But again, I think this is an amazing possibility, and this will unlock a lot of use cases for dApp developers. Okay, so the TLDR so far of StarkNet accounts is that accounts are smart contracts and they must be deployed. That's something that you need to keep in mind when you're building a dApp. The address of an account is computed as a smart contract, so it's not derived from the signer like on Ethereum. It's a smart contract, and so there's no link between the keys that may authorize transaction and the address of the account. Because accounts are smart contract, they may receive multiple signatures. So for example, an account could be a multi-sig, and so the signature to approve a transaction can actually be an array of signature. So if you make assumption on your signature, make sure that you assume that they can be an array. Off-chain signatures must be validated on-chain by the account. So that's the isValidSignature I showed in the previous slide. Meaning that if in the flow of your dApp, for example, you ask users to sign some kind of message with the account, you cannot verify this signature locally using something like EC Recover. That was okay on Ethereum because, again, the address of the account was derived from the private key, and so you could verify a signature off-chain in your dApp. With StarkNet accounts, only the account can tell you if a signature is valid, because maybe between the moment the message was signed and the moment you want to verify, the signer key has changed, the authorization on the account has changed. So the only way to check if a signature on an off-chain message is valid is actually to ping the account and to ask, is this signature valid? And finally, you can use multi-calls. So, and actually you should use multi-calls if you're building a dApp. So these 5 things are literally all you need to remember about StarkNet accounts. Okay, so that was a recap of what StarkNet accounts are. Now let's see what actually we can build on top of that. And so now I'll focus on Argent X. So what is Argent X? Argent X is the first wallet on StarkNet. We are no longer the only one. There's also Bravos, but we are still the main wallet on the StarkNet ecosystem by far. It's a browser extension, so it's available on Chrome and Firefox. It's multi-account, so you can have multi-account for say different dApps. For example, you can have a first account holding the majority of your fund, and you can have another account that you'll use to experiment and explore, for example. It's multi-StarkNet network, so it supports Girly testnet and mainnet alpha. You can, of course, send and receive tokens and NFTs as you would expect. You can connect to dApps, and it's 100% open source. This last fact is important. We do encourage, people to contribute. So if you feel that, you want to add something onto Argent X to improve the experience of your dApp, please submit a pull request. I mean, we would love to receive external contributions. A few numbers about Argent X. We actually have already a lot of users. I mean, it's been an amazing ride so far. We have a lot of funded accounts. As you know, StarkNet is on mainnet as well, and the bridge was open something like a month ago, where they gradually increasing the amount of funds that can be bridged to StarkNet mainnet. And basically today, all these funds are secured by Argent X wallets, which I find quite exciting. So how does Argent X works? So typically in Ethereum, if you think about a wallet, you have a UI and you have a key. Following what I've been discussing so far, on StarkNet, it's a bit different. You have a UI that the users can interact with. There's a key that can sign transaction, and there is on-chain an account contract or multiple account contract, because Argent X is multi-account. So when you think of an account, you need to think about these three objects. So the way to use Argent X, very, very normal, as you would expect it, similar as a MetaMask, for example, on Ethereum. If you go on a dApp and you click on a button to do some transaction and contact the dApp contract on chain, it will trigger Argent X to open. We will show you the detail of the transaction. The user can approve. At that point, the extension will use the key to sign the transaction, send that to the account contract on chain. The account contract will verify that the transaction is valid and authorized, depending on the custom logic of the account, and will then relay the transaction to the dApp contract. So this is a typical flow that you would expect, except that now there's an account contract that sits between the extension and the target contract that you're trying to reach. Because you are a whole developer, as a developer, there's actually an additional step. If you build a dApp in StarkNet, you'll probably use StarkNet.js, which is a JavaScript library that enables you to interact with StarkNet. And so typically, you will use StarkNet.js and get StarkNet, another library that will inject a wallet into StarkNet.js. And so you can basically program your dApps against StarkNet.js, and using getStarkNet, the wallet will be automatically injected into your dApp, such that every time an action is triggered, the Argent X or the wallet extension will open. Okay, so now what can we do? What have we done so far with Argent X? So one thing that I mentioned already is the concept of multi-code. So I want to come back to that because I think it's very important. It's one of the amazing things that account abstraction can enable. And I think as that developer, you need to get used to it because it will really improve the user experience of your dApp. So the idea of the multi-code is to actually execute a sequence of operation in one atomic transaction. Okay, so a typical example, for example, is if your dApp needs to consume some token to perform an action. Typically on Ethereum, this will require two transactions and two buttons on your dApp. First, the users will have to approve the token. And then when that transaction is mined, it can make the second call, which will ping your dApp. And then at that point, the dApp can consume the token. So it's actually a painful experience on Ethereum. With the multi-call, all this can be executed in one transaction because you can provide an array of calls to your account. And because your account is a smart contract, it can actually orchestrate the execution of all these calls. So in terms of UX, much better. There's basically only one click for the user, only one transaction to sign, even for complex interaction. And also on StarkNet, it can actually save a lot of gas. So it not only improves the user experience, but it also saves gas for the user. Why? Because on StarkNet, the majority of the cost that you pay for a transaction comes from pushing the state diffs to L1, because we are in a ZK rollup mode. Okay, but with a multi-call, it is very possible that some of the state may be rolled back at the end of the transaction. If you think of an approve and a call, for example, you first need to approve a certain amount, but at the end of the multi-call, all the approved amount has actually been consumed. So that storage slot was 0, goes to a certain value, and then at the end of the transaction, comes back to 0. So there's no state difference being pushed to L1. So actually leveraging multi-call, you can actually greatly reduce the cost of your transaction. Okay, and so you see in that screen there, for example, that's a typical example that you can do with a multi-call. We are swapping some BAT for DAI, for example, on JDAI swap. And in the same transaction, we are sending 50 DAI to one user and the remaining of the received DAI to another user. So all this will happen in one atomic transaction thanks to multi-calls. So that's something that's already available on Argent X today. And I would strongly encourage you to leverage it if you're building a dApp on StarkNet. Another thing that we've built is what we call transaction review. So too often on wallet, it's difficult to understand what you're assigning because it can be called data, it can be fields, it's hexadecimal. So the idea of a transaction review is to display the information in a human readable manner so that the user can actually understand what he's about to sign. Okay, and we can actually go one step further because we can, based on the action that's about to be executed, we have built a service that can actually evaluate the risk of the transaction. For example, if you are interacting with a known dApp, so we know the dApp, we know the smart contract. For example, you're swapping on a known DEX, we know the contract, we know that what you will receive is at a fair market price, then we can actually tell the user, this is verified, everything is good. You can actually interact with that dApp and execute that transaction in confidence, you are secure. On the other side of the spectrum, our service can detect if a transaction is a bit dodgy or a bit risky. For example, it happens more often than we would imagine, but users are sending an ERC20 token to the ERC20 token contract itself by mistake. So again, that's something that our service can detect, and we can show a warning to the user, say, hey, just please double check because what you're about to make is probably not a good idea. So that's something that we provide to the Argent X, the concept of transaction reviews. Another thing that we've just added and announced last week is that we now support fiat to crypto on RAM. So we've partnered with Banksa, and you can actually now buy ETH or DAI on StarkNet mainnet using a credit card or a bank account. So that's pretty exciting. We are also working with LayerSwap to enable users to bridge funds from a centralized exchange, such as Binance or Coinbase. Okay, so these are some of the features that we have today. Of course, you can do everything related to token. We've integrated, with Aspect for supporting NFTs. So, I just showed some of the unique stuff you can do thanks to account abstraction, but of course, we do all the basics and everything that you would expect from a wallet. So we have a lot of cool stuff coming in the coming weeks and months. An initiative we are currently working on with Ledger is to integrate Ledger in Argent X. So you will have the possibility to create an account on Argent X where the key is actually not stored in the local storage of Argent X, but the key is in your ledger. So that's something that will come and which we are quite excited about. Another thing that is enabled through account abstraction, and that actually is already supported by the Argent X account contract. It's not yet surfaced in the UI, but actually the account contract that you have with Argent X already supports the possibility to do some fraud monitoring. So what's the idea of fraud monitoring? Because your account contract can be programmed, there's one key that's the main signer of the account, but if you want, users can add another key and say that this key needs to co-sign every transaction. And now you can imagine that you give this second key to a service. And that service, for example, can be exactly the same service that we use for our transaction review. Except that now, when the service detects that the transaction is verified, the service will automatically co-sign, so completely transparent to the user. If the service on the other side of the spectrum realize that you are about to say to call a dApp, that has been blacklisted, an evil dApp, for example, then the service can actually refuse to co-sign, so you are safe. And if it's in between, so with your Argent X wallet, you're about to sign something that the service doesn't know, then maybe it can ask you to just, confirm who you are with a second factor via email, SMS, Google Authenticator, and so on. So again, it's exactly the same flow that you would expect from a modern banking application, but we can reproduce that on Argent X, fully non-custodial, because as the owner of the wallet, you control who you give that key to. So it can be a centralized fraud monitoring service, say provided by Argent, but it can also be you with a hardware wallet if you want. There's a lot of possibilities. Another thing that we are working on is social recovery. For those who know Argent, we've actually pioneered social recovery on Ethereum layer 1 for the past 4 years, and we are bringing that to StarkNet. Again, this is something that's already supported by the Argent account contract. We still haven't surfaced that in the extension in the UI, but this will come in the coming weeks or month. The idea of social recovery is, again, to say that because you can program your account, you can actually add a second key to your account. That key cannot trigger transactions, so it cannot transfer token, it cannot do anything. The only thing it can do is to add a new key as the main signer of the account. And so the goal of social recovery is that if for whatever reason, say you lose your computer or you lose your private key, at that point, you can contact the recovery service, which we call Guardian in the Argent world, and say, hey, can you reprogram my account and set a new key as the owner of the account? And the recovery service can do so, and you gain back access to your account. Why is that interesting? Because it's actually a way to get rid of seed phrase, which we believe is one of the biggest pain points on blockchains in general for mainstream adoption. And so through recovery, you can actually get rid of seed phrase because you no longer need to back up your seed phrase, your private key. If for some reason you lose it, you can just contact your Guardian and they will give you back access. Again, it's a protocol. So at the level of the account contract, the Guardian can be anything. So it can be a centralized service that you trust and that will ask you to authenticate with two-factor, for example. But again, it can be yourself with a hardware wallet. So you can have an Argent X account where you have a main key in your browser, local storage, but actually your Guardian is a hardware wallet that you don't need to use, that you can keep safe, it's secured in a safe. And the day you lose your computer or you lose access to your Argent account, you get your hardware wallet and you trigger the recovery procedure and you will get back access. So again, 100% non-custodial, fully under the control of the user, but it's a great way to get rid of seed phrases. What else? Another thing on which we are working at Argent is the concept of plugin. And that's something that we are doing in collaboration with Ledger. So the idea of plugins is actually to enable extend features on your account contract. So you would have a basic basic account contract, but on top of that, you can enable some plugin with custom logic depending on the use case. Okay, and the way it would work is that when you're making a multi-call, the first call of your multi-call would say use this plugin, and automatically the account will check has this plugin been authorized. If yes, then it will delegate the execution to the plugin. So that's a way to add more feature on top of the account, the Argent account, and make it a bit more modular, make it a bit more like a platform. And the first example of things that we are building using this concept is the idea of session keys, which we believe is very relevant for games. So the idea of a session key is actually, I mean, as you probably know, when you're building a game on chain, one of the main pain points for users is that every time they make an action, they need to approve the transaction in their wallet. And that means that users are constantly switching between the game and the wallet, which is not a great user experience, of course. So session keys can solve that. The idea is that when you start a session, so when you start playing a game, the game will actually generate a key locally and ask the user to approve that key on the wallet. So that means that now this key is authorized to make transaction on the account, but not any transaction. You can actually attach a policy to this key. For example, you can say this key that was generated in the dApp can make transaction for 35 minutes, and it can only call one contract and one method on that contract. So very secure, very restricted. Why is that interesting? Is that now that this key has been approved, you no longer need to see your Argent X wallet. Every time you make an action on the dApp can directly send the transaction to the target account on chain, which will execute the action. So now you have a way to make the wallet transparent. So your users can remain focused and can stay in your game, but still as a user, you are fully in control. Everything is completely secure because this key is attached on-chain to a very strict policy which defines exactly what the key can do. Okay, so the idea of session keys is really a way to make the wallet more transparent while being secure. So these are some of the examples and some of the stuff that you can do through account abstraction and that you can do on Argent X today or in the coming weeks. Of course, there's much more coming, so I would invite you to keep paying attention to what we are building. As a dApp developer, it's actually very simple to leverage Argent X or leverage a wallet on StarkNet. It's the only thing you need to do is to use StarkNet.js and combine that with get StarkNet, which will inject the wallet into StarkNet.js and into your dApp. So again, for you as a dApp developer, you just need these two libraries and you are good to go. You will have wallet support on StarkNet. And with this, I've reached the end of the talk. So thanks for listening. Please check our page on argent.xyz. Make sure you install the extension. And again, we are an open source project, so feel free to contribute or reach to us for collaboration. We would love that. My pleasure. Thank you. Bye.